The maximum, what do you think the maximum of something is going to be?
The highest.
The highest or the biggest? Yep. Can I have that set of notes back, please, since they're absent? Is there a set of notes back there? None went back there? Okay. Thank you. All right, and the maximum is going to be the highest point of the function. Remember, a function has to have only one y value for every x value. The highest point of the function. All right, so it could look like this. It could be from a quadratic function. It could look like this. It could be an absolute value function. But it cannot look like this. This one doesn't have a maximum. How come? Keeps going. It doesn't turn around and go back anywhere. So this one has none. And the minimum would be the excellent, the lowest point on the function. All right, so the first part is pretty simple. Letter A, what's the maximum or the minimum if one exists? Do you see any highest point or any lowest point? No, that one has none. Now, when we break it up into the piecewise parts, you might be able to find one. I don't think we'll get that complicated until next year. Letter B, what do you see? A maximum or a minimum? 2, 4. Do we call that a maximum or a minimum? Maximum. Can anybody give me another word for that from everything we did with quadratic functions? It's a quadratic graph. Come on, it starts with a V. Vertex. Good. The maximum is also the vertex. Excellent. All right, letter C. What do you see there? Max or min? Min. Be careful when you're reading graphs. This one doesn't follow every grid line. This is -2, and this is -4. So where's ours at? -3, -5. It's halfway between the -4 and the -6, and that's the minimum. All right, you'll have some homework problems like that. Now, yesterday, what happened as he was climbing up the mountain and you looked at different hours of his drive or his ride up? What happened? As you were graphing Andy's ride up the mountain, what happened over that graph? From different times.
Oh, the cut.
It cut into
The
different pieces, piecewise, yep. The hours from 0 to 2 did one thing. The hours from 2 to 4 did something different. So those are called intervals. The interval is the piece or the portion of the graph. I'm going to say piece just because it fits nicely with piecewise. Some definitions say portion. It's the piece of a graph when you're just looking at a part of it. So look down here at the definition and how this works. Here's the original graph. But over here they say look at just the interval from x equals 2 to x equals 4. So we're going to do that sometimes. We're going to break it up into just certain parts of it. So what you do is you go to the 2 right here, and you break it up here, and you go to the 4 and you break it up there. That's an interval from 2 to 4. With this notation, when you're saying from 2 to 4, it doesn't tell you if the 2 is included or the 4 is included. That's slightly different than yesterday. So the interval between 2 to 4 just looks like what they have over there. This is the piece, and they drew it for you over here. Okay? That's all that means. Any questions on that? So look down below. Identify or highlight the interval requested. For letter A, it's -1 to 3. So all you have to do is find where x is -1. Sorry, I'm trying to get this. Question? Things going a little wacko. Okay, so all you have to do is find the graph from x is -1 to 3, and in this case, we'll highlight it. So you find x is -1. That would be right here. So break that off at the -1. Where else should I draw a cutoff line? at the 3. 1, 2, 3. X is 3 right here. Yep, that's the positive one. So the interval would only be this piece right here, and I'll do it in green. The interval that they would only want you to study or redraw or focus yourself on this piece of the graph right there. Incidentally, what kind of graph was that original?
Quadratic. No, it was absolute value.
Exponential. Absolute value has to be a V. This one's like an upside down ramp. That one's exponential. The middle one's is the one you meant, right?
Yeah.
This one right here, absolute value, the second one. But this time, they want us to state the interval. So where does that graph, this upside down absolute value one, where does that graph begin? You say from x equals what? Negative 5. And what's to positive 2? Okay, and that's what they want from you. Okay. So try the next two on your own. If they give you an interval, highlight it within that graph. Just find that piece that matters. If they don't give you an interval, then you decide what the interval should be. Letter C went from what to what? 0 to 4. Good. And it's only interested in the x-axis. It's only interested in what's called the domain. But letter D, the part of the graph you should have counted, starts at 0 and goes to 1.5. That would be halfway between 1 and 2. So the part of the graph that you care about would be, this piece right here. Any questions on intervals? No. Okay, ever see that kind of graph before? You will in probably trig. All right, turn the page, please. Okay, a graph is said to be increasing if the y values are increasing as you go from left to right. We're going to get used to reading our graphs going from left to right. In other words, the graph goes up if you're reading it from left to right. And decreasing would mean that the y values are going down. And in other words, the graph goes downward. All right, and it can change from one interval to the next. All right, so this time you have to identify where the break happens. So we want to say where this graph is increasing. So write down underneath increasing. We'll give one interval, and then write decreasing. We'll give another interval. Where does it start to change? What x value is the changing point? 2, right here. This is where x equals 2. So what part of that graph is increasing from what value to what value? You know what that word is when it keeps going and going and going? Infinity. Yep. From x equals 2 to x equals infinity. There's a positive infinity and a negative infinity. So just be careful about that. So x is 2 to x keeps going on and on and on and on forever. This graph is increasing. Now where is that graph decreasing, going downhill? Where does it start? It ends at 2, right? Where does it start decreasing? -3, -4, -5. It's from negative infinity. It doesn't have a starting point. You said that? I didn't hear it. I probably looked at you like I couldn't hear it. X equals negative infinity, and then it stops where? Stops decreasing at the 2. X equals 2. All right, letter B, what's the point of change? Where's the breakdown point here? -4, good. So we're going to be changing at the -4 right there. But let's do increasing and decreasing. So where does it increase? Where does it start increasing?
Oh wait, we're doing increasing?
Increasing, yeah.
Oh, negative, what is that?
You could say -4, except see this line, it just keeps going past the -5. It just keeps going. So we're going to call that negative infinity. Good. Increases from negative infinity to -4. X equals -4. And I'm sorry, my writing is going past where it should. All right, and it's decreasing from where? -4 to positive infinity. It just keeps going and going and going. If you know the symbol for infinity, you can use it. All right, and where is letter C decreasing? Decreasing? Anywhere? Does it decrease anywhere? No. So it doesn't decrease at all. Where is it increasing? All right, if you thought of that as being cut off there, it could be -1 up to 4, but it's also, just as a general function, is from negative infinity to positive infinity. And for your homework tonight, unless it makes it very clear that it's stopping there, like there's nothing after it, then consider it that it's going and going and going and going. Because unless you cut a function off, it keeps going. All right, and the last thing that's new to you is the bottom. Do you guys know what average rate of change means? Does anybody remember that from last year? What does it make you think of? Math-wise. Slope. Yep. Average rate of change is like the slope. Okay, but the average rate of change, we don't have all lines here. We can't count it perfectly like a slope, but it's a slope of a piece of the graph. The slope changes. Sometimes it's shallow, sometimes it shoots straight up. So you have to find the different parts where the slope could change and where you could calculate it. So there's one way, which I'm not going to do. You find the point x1, y1 at the beginning of the interval. Well, I'll do this part. I'll show you the second part though. And then at the point x2, y2, you find that point at the end of the interval. Then you either use a slope formula. Who remembers the slope formula? That's the slope-intercept form. Good. The slope itself is y2 minus y1 over? Good. Okay, you can subtract that and you can work that out. If you love formulas, that's great. I don't. I like to count things. It makes it go faster for me. So what I'm going to do is count the rise over the run. Good. So I have to calculate how high it goes up or down, and then I'm going to calculate how far it goes left or right. All right, the trick is to look at the different intervals. So if we're going to look at, and these intervals are going to change, so I hope you're just in pencil because you might have to erase it or maybe do different colored pencils because these are changing. So the first one says from x equals 2 to x equals 3. So I'm going to look at my 2 right here. X equals 2 and x equals 3. I'm only allowed to look at that part because that's the interval. So you have to look at the starting point here and the starting point there. Okay? 1 over 1. That's right. Up 1, right 1. Okay, so don't make this harder than it has to be. If you can find the beginning point, the ending point, then it equals 1 over 1 or just 1. Are there any questions on how I got those 2 dots? That's probably the hardest part of this. Identifying the starting point or the ending point. You're okay? All right, let's try one in pink. The pink lines are supposed to go from x equals 2 to x equals 5. So I'm supposed to use this one again. But I'm supposed to go up to 5. So my first dot is right here again. But my second dot changes. I have to use the pink lines from 2 to 5. So I find this dot right where it crosses, right there. Okay, the hardest part probably is just finding the dots. Because I look for where my graph crossed my interval line. And this one said x equals 2. So I drew another line, a pink line at 2, and I saw that it crosses my exponential graph right there. Can you see where they crisscross? Yeah. And then it said x equals 5. So I drew a line blocking it off at the 5, and then I saw where does the purple line right here connect with that interval, and it ends right there. So now I count the rise over run. 7/3. You guys saw it already. And that one can't reduce. So just let me show everybody. 1, 2, 3, 4, 5, 6, 7. That's up, so it's positive. 1, 2, 3. That's right, so it's positive. 7/3. For letter C, one like letter C, there's a slight problem. This graph never ever becomes an actual number. It infinitely gets smaller and smaller and smaller and smaller and smaller, but it will never cross the -2. You'll get into that more in other days. But for this one, let me do it in blue. We're supposed to go from the -5, which is all the way over here, to +5. So we go back to this one again. I'm going to just erase all the other ones just to make it easier on you. So I just erased the other ones. So we're going to start with -5 right here. And it crosses right there. That's our beginning point. How do I find my ending point to count to? The +5. Good. So draw a vertical line going down at the +5 and see where the interval ends. Because what we're really looking at is this interval right here. That's what they want. So it has a beginning at the first cutoff and an end at the second cutoff. Now that's not true slope. It's not a straight line, but we're going to find an average rate of change by counting up and counting right. So it goes up 1, 2, 3, 4, 5, 6, 7, 8. And to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's an average rate of change. But you should write it a little bit better. How should you write it? 4/5. 2 on your own. Maybe 1 on your own. All right. Where do you see an equation saying x + 5? And I'll tell you what, piecewise functions always go from least to greatest. Okay, we always read graphs from left to right. So this first interval, this first part of it, is from where to where? See how this one has an ending dot right there? Yeah. That means it's ending. So we're not going to say it keeps going, I don't think, for that one. You know what? I'm going to change my mind on that. I'm going to use the word infinity. Okay, so that one, unless it tells us that it's stopping, we're going to say x equals -infinity up to x equals what? Where does the graph start to change? -1? No, it's going up and up and up until what? -2. Good. From x equals -infinity until the -2, it's going up and up and up. Then it turns and starts to go down. How far does it go down at that same way? What's that interval right there? Okay, that's where it ends. Where does it start? -2. Good. So we're going to count it from -2 to x equals -1. All right, I'm writing it out, x equals to x equals, because that's the way the notation that that they want us to do for assessments. If for your homework, if you write x equals -2 to -1, it's not technically wrong, but I'm going to write it out the way that they're going to want to see it on assessments. Next one, where does this quadratic one go? From what to what?
From -1
to +1. Yep. And the last one, it's a slope. If you kept going on this one, it would hit the y-intercept at 1/2. Okay. So the actual thing is from 1/2 it goes down 1, right 2, down 1, right 2. But what's the interval for that one? From x equals -1, I'm sorry, +1 to infinity. To x equals infinity. I know it's a kind of a pain to have to rewrite that every time. Okay, so you're going to have some on your homework, which asks you to identify the interval. Let's try letter B, where you actually have to write some equations as well, some functions like yesterday. All right, so look at the one from negative infinity up until you get to negative 1. We're going to write the equation of this. What is it? Linear, absolute value, exponential, or quadratic? Linear. When it's linear, it's easiest to find the slope and the y-intercept. What's the slope? How much is it going up and over? Up 1, right 1. So we're going to say 1x plus, you don't see it crossing the y-axis, but if you took your ruler and you kept it going, sorry, I'm short, and you kept it going, where would it cross the y-axis? What would the y-intercept be? 2. At 2. So that's the equation of that line. Slope of 1, y-intercept of 2. Where's the interval, where it's just always 1? Y equals 1, y equals 1. What's that interval? Okay, when you graph a horizontal line, this is y equals 1, this middle part, because x can be whatever, but y is 1 all the way across. From negative 1 to x equals what? 1. Yep. You did, but I want to get everybody there too. I know I heard you. I heard you that time. All right, for the next one, what would the actual interval be? Let's do that first. Where's the break off? Where does it start? X equals positive 1 and x equals infinity. Okay, now I know that looks like a line, but it's not. It's curved. Now imagine in your mind, don't do this on your paper. Just let me do it here. Imagine in your mind if I followed that along its curve and I went down like this. Okay, what would that be? What would that be? Would that be exponential, quadratic, linear, or what? Quadratic. Good. It starts at the 0, 0, and it just goes up 1, right 1. That's an x squared type of function. Okay, we've got 5 minutes left, so let you try letter C on your own. First line is blank, so what would y equal when you're going from here all the way across? What does y equal on that horizontal line? All right, so let's do the intervals first. Negative infinity to what? What's the breaking point? Negative 1. And then the second part of the graph goes from negative 1 to positive infinity. Did anybody figure out what would y equal if you have a horizontal line like that? Y equals 1. Yep. Okay, because negative 5, 1, negative 4, 1, negative 3, 1. Everything is y equals 1.